Okay, let's take a look at 6 now. So 6 is basically we have 5 pastas, 4 flavors. Basically what we got is they want to know what's the probability that we'll end up bow ties, cheese sauce, or both. So really I'm thinking this is bow ties or cheese sauce or both. So we're dealing with an or statement. And we know our or statement should be probability of A plus probability of B minus probability of A and B. And we know we actually have an A and B in this case because you can have cheese on bow tie pasta and it's delicious. So what we got is probability of A is 1, so 1/5. So there are 5 of those guys. And the probability of getting a cheese sauce is 1 out of 4 because there's 4 of those and we're adding them, right? Now we have to do the probability that you are both a cheese sauce and a bow tie, which is 1/5 times 1/4. And we get to multiply them because I know that cheese sauce and bow ties are independent of each other. Actually, I don't know that, but we're assuming that. So we get 1/5 plus 1/4 minus 1/20. And we say 20th because 5 times 4 is 20. Now common denominators 4 and 4 and 5 and 5. And then we get 4/5 plus 4/20. Sorry about that. Over 5/20 minus 1/20. And I get 9. So that's 8/20. So that seems reasonable. But let's take a look at this maybe just slightly different. Maybe slightly more useful, I guess, geez, too far. So yeah, let's make a tree diagram. So if I was to make a tree diagram, it's going to be a little bit messy, but we'll do it anyway. So 1, 2, 3, 4, 5. And what do we have? We have spaghetti, bow ties, fettuccine, ravioli, and macaroni. And off each one of these, we have another 4 branches. 1, 2, 3, 4. And this is tomato and cheese and meat and olive oil. So then 1, 2, 3, 4. And we have tomato, cheese, meat, olive, and then we got 1, 2, 3, 4, 5, tomato, cheese, meat. Oh, I did 5. I don't need 5 olive oil. Let's just forget that ever existed. And then we got 1, 2, 3, 4, tomato, cheese, meat, olive oil, and 1, 2, 3, 4, tomato, cheese, meat, olive oil. If we add up all these, we have 5, but each 5 has 4. So that's 5 times 4. We have 20 options. And now let's find out what we're going to get. So if I want bow ties, well, how many bow ties do I have? Well, I have a bow tie here and a bow tie there and a bow tie there and a bow tie there. That's 4 bow ties. So we have 4. Sorry, guys. We have 4 bow ties. Now let's see how many cheese sauces we have. Let's, I don't know, we can do yellow for cheese sauce. Well, we got cheese sauce here. We got a cheese sauce here. We got a cheese sauce there. We got a cheese sauce here. And we got a cheese sauce here. So that's 1, 2, 3, 4, 5. So we had 5 ways. We have 5 ways to get a cheese sauce. Now we have one problem though. Do you see that I counted this guy here once and I counted it for cheese sauce? So he got counted twice. He really only needs to be counted once, right? Because that's your both option. He exists, but he doesn't exist twice. He doesn't have twice the probability of happening. He's only one line on my graph. So we have to subtract him out. How many of those guys were there that were both? 1. So we have 4 options and 5 options and 1, and that gives me 8 out of our total number of lines, which is 20. That's a beautiful thing. And that's how to do number 6.